much to MUTEK and for Codemy for putting this all together. If you're just joining in, I'm not sure exactly where I started, but that's okay. It's fine. Okay, so basically this is the workshop, and we're about to endeavor over the next hour. So what we're going to learn is that we're going to learn how shaders are made, and we're going to write some shaders together. And some context for if you're familiar with like MUTEK, a lot of the different programs that are run are using shaders because shaders are very, very good at live graphics. The reason for that is because shaders are low-level code, which means that it's closer to the metal of the machine. Let's just say that. Yeah, opening glitches in the new world, that's right. I was just looking at my phone. Okay, so anyways, providing context of like what you're about to learn in relation to MUTEK is that a lot of the visuals that you see are using shaders because shaders are very good at real-time graphics, which means that they can get input real-time, aka like live music, and then respond to them, or get input from dancers, or get input from singers, input from proximity, so like audience members and stuff like that. They're very powerful. They're used in context. They're used in processing, which is a very popular graphics programming wrapper for Java. They're used in open frameworks. You can use them in open frameworks. You can use them in Touch Designer. You can use them in basically a lot of any sort of like graphics pipeline, any sort of like graphics graphics program. You can use shaders, or it uses shaders under the hood. So it's a way to program the GPU. Short and sweet. Hi, I'm Char Stiles. Teaching assistant is a Montuar. I'm not sure if he got in the chat or not, which is like fine. I know this is like tough for everyone, especially because like I'm on first. Whatever. We only have an hour. We're just gonna go with it. And Codemy was the group that I am with. Through in MUTEK. So Codemy is a space in San Francisco that puts on events and workshops specifically at the intersection of art and technology, and they're a wonderful group of people who create this space for artists to experiment and be able to okay, I just want to see. Yeah. Anyways, so okay. So GLSL is OpenGL shading language. It's like programming language that allows you to code graphics directly on your graphics card. And I have the links to what we're going to be using. We're going to be using this online editor, so there's no download necessary. And then I have the presentation slides, and then we're going to go over exactly what these are in later. And then how this workshop works, if you're just joining us, basically I'm going to have 4 different checkpoints for if you want to copy and paste the code into the force, see what we're going to be writing or what I'm going to be writing, and then see me write that code live. And so you get these 2 different perspectives of the code. Or you can follow along with me and type along with me. I recommend that if you have 2 screens, you do that. And then use this code to kind of go back to it later, because the code that I'm going to be writing is almost exactly the same as the code here, just without the comments. Here, these snippets of code are short, 36 lines, right? And there's a lot of comments, so I explain every single piece of code, but still, I believe that if you're going to be needing the supplement of having a teacher explain it to you. Which is always helpful. That's how I learned. Okay, so let me get back into my presentation. So basically, just to recap, hi, I'm coding shaders. I'm Char. I use shaders for performance a lot of the times. That's just kind of like the context of where I'm coming from. I live code shaders, which means that I will code the visuals on top of the graph. I'll put the code on top of the graphics that I'm rendering, so you kind of have this like one-to-one correspondence. And it's not something that I made up. It's from a community of people in the live code scene, and so people will live code music and or visuals and present the code on top of that as part of the performance. So you can see the algorithms that are creating the things that you see and you hear. Our TA is Aman Tabari. Hopefully, Aman, did you get in the chat? Maybe he has his headphones on. So he's going to be in the chat answering your questions. He's an amazing shader writer. He's like,
is that the right path?
No, you're supposed to go on nexus.mutek. Oh, you're here. Okay, cool. So Aman's here. He's going to answer your questions. He's a great shader writer. Some of the, maybe the best shader writer I know, including myself. Anyways, that's beside the point. So I'm not going to read this because I went through it already, but if you go to toplab.org, it's the kind of the hub for live coders to like share their stuff and get excited about algorithms, which is a portmanteau of algorithm and rave. And yeah, just all stuff about live performance and code. Very, very cool. So what are shaders? What are they? Where are they? Who are they? So some people say that shaders are wizards on your computer that do math and then spit out visuals. But nah, we're not gonna, yeah, no. So what they are, they're tiny programs run on the GPU that run per pixel. So if you have an HD screen 1920 by 1024, if you have, it's running at 60 frames a second, that is over 100 billion times per second. I think you're supposed to. Is my keyboard broken? I think it is. Okay. Wow, it's a lot. This is the graphics pipeline. It's a way of thinking about how graphics render on your computer. This is specifically the rasterization pipeline. You might have heard, if you're like into gaming, you might have heard talk about ray tracing. This is in contrast to ray tracing, and so this is what's popular right now. And will be popular for a while until the ray tracing pipeline kind of takes over. But anyways, this is graphics pipeline. So you have a vertex shader, which will change the vertices in your 3D model. So for example, if you have like an OBJ, that can be changed by a vertex shader. And then the vertices get passed into the tessellation shader, which then gets passed into the geometry shader, which then gets passed into, tessellation and geometry are optional, and then vertex post-processing, primitive assembly, rasterization, the fragment shader. We're going to be using just the fragment shader on this online editor. Okay. Okay, cool. All right. All right, so let's just get right into writing the code. Laptop time. I recommend you get your chargers out. Go to charstiles.com/livecode. This giant link right here. Okay, cool. So if we go to that link, I would love to get feedback at this moment, but I think that's fine if it doesn't happen. Oh, I see it. Oh, they spelled my name wrong. Oh, I see. Oh, they spelled my name wrong. I see. Okay, I understand how it all works. I see everyone. I see rooms, others seem to work. There we are. There's everyone. Is this workshop happening? That's right. Thanks for sticking with me, and I'm so happy to see that there's people here. Oh, there's workshop. Okay. Okay, so this is the workshop link, and so basically here on the Okay, so now that I can see the chat, feel free to ask questions in the Codemy chat. I would also really appreciate any sort of you know feedback just for me. Yeah, just for me, and for because as we're figuring this out, it's always good for me to have feedback. It just makes the experience better for you and for me. Great. You don't have to laugh at my jokes. I know. Okay, just kidding. Okay, so here is the force, which is the editor that we're going to be using. Like I said before, if you open it up, you'll see this. It's just supposed to be black and say this. And I'm going to go over the tools later and the checkpoints. Okay, so we're going to start writing the first checkpoint. So if you're following along if you don't want to follow along with the code and you want to just copy and paste the code in, open this up, and then you'll see here, and a good way to get the code really quickly is if you click this raw button. I know it's like over my thing, this raw button right here. It'll bring you to this, and then you can just Command A, copy, and then Command P it in here. But I'm going to write it out. So basically, let me make this bigger. Okay, so here's the force. It's an editor made by Sean Lawson, who is a live coder in New York City. Oh, sorry, in New York. He's upstate. It's open source, and it's really wonderful that he's made this for people to use. He uses it for his performances, and so yeah. And he's also really open to any sort of like pull requests or anything like that. If that doesn't make any sense, don't worry about it. So here, let's get started on what the shader is. The shader is, in one line, it is an input of a position and an output of a color. And I know that sounds really simple at first, but as we get into it, it'll start to be clear on what makes that more complicated, how that makes it different from other graphics coding languages. So the input is a position, the output is color. So how is this color? So you see right here, GL frag color equals this vec4 black. This is our output. And a color in this case is a vector 4. And what a vector is that it's a holder like a bin for 4 numbers. That's the vector's job. It holds 4 numbers. And so here we see that the vector 4 is holding black and then 1 number. This is actually shorthand for, well, oh, sorry, black. I'm like, okay, so that's shorthand for that. And that means is the red channel is 0, the blue channel is 0, the green channel is 0, and the alpha is 0. Colors in GLSL range from 0 to 1. And so if I were to make this 1, it'll be all red. And the reason why what this alpha channel is that's because if we were to be rendering this with other geometry, we would want to be able to like see through it, for example. We would want that, but we don't need it in this case because we're basically just rendering it on just 2 triangles. I know that doesn't make sense if you're just getting into this, but if you know any graphics, that'll be like, oh, okay. So this is actually using a vertex shader, but you just don't see it. That's for the graphics nerds out there. So anyways, now you know what a vector 4 is. Now you know what a color is. A color in this context is a vector 4. It holds a red channel, a green channel, a blue channel, an alpha channel. How do we get the position in? Because remember I said a shader is just has the position in and the output is a color. So the position is a coordinate. And a coordinate needs an x value and a y value. Think about like high school math. The coordinate system, you need an x value and a y value. So as you can imagine, that is going to be need a vector 2. So something that'll hold 2 floating point numbers. How you create that is you first have to tell the force that you're going to be using a vector 2. And so how you do that is you declare, say this is going to be a vector 2, you tell it what the type is, and then you name it whatever you want. I'm going to call this v2 equals, and then you need to cast cast. When I say cast, I just mean tell again, like what type this is. So there's different types. There's vector 2s, vectors 3, vector 4s, and floating point numbers. And in the force, oh yeah, we can get a vector 2. I don't know why I did this. Yeah, so we've got a vector 2 that's 0, 0. But if we wanted to get the position, this is specific to the force, we use this function called UV. And where I got that is that in this question mark down here, you can see all the different, under add-ons, you can see that UV function right here, this pixel on screen, what coordinate system is width, negative width divided by height to width over height, height negative 1 to 1. So basically that's telling you that it's returning the position of the pixel from negative 1 to 1. So if you wanted to double check that, you might think like, oh, I can just print it out to the console. Unfortunately, there is no console in shader code because it is executed on the GPU, which doesn't have access to print anything. So you technically could run it through the CPU first to check for print calls or whatever, like something like that. But that would just take too long. So in this case, we're just going to have to learn to debug with colors, which is really fun. So let's, so if we wanted to view the vector 2, we can construct a vector 4, again, holders for four numbers. We can put the first two numbers as a vector 2 as 1, which is really cool. That's specific to this version of GLSL. You can do this. And so I can put V2 here. And then we see that it's rendering, the input is a position, the output's color. Finally, we're actually writing a shader. Cool. And I see people are giving me cool emojis. What is this? Oh, this is so cool. Okay, cool. Now we have that. And if we look at the checkpoint code, what we're supposed to be writing is this right here. It already kind of starts to look like that. We have our fade going from left to right. It just, this is actually moving. I didn't record a GIF, but I should have recorded a GIF. So we see here that the red channel is this kind of like phasing going across the screen. The green channel is are these stripes going up and down, right? So the stripes are vertical, and I'm sorry, the stripes are horizontal and the red is vertical. And then the blue is this kind of like ray effect. So let's break it up. So we don't get overwhelmed. Let's break it up into the red channel, the green channel, and the blue channel. So much like vector 2, we can declare the red channel is just a float. Let's call this R, and then we're going to want I'm going to rename this, instead of V2, I'm going to rename this pause for position, because that is a more descriptive variable name. So we want R to be going from left to right. So we want the red channel to be a function of the x position of the position on the screen. So if we say R equals pause.x, and what I did here is so pause is a vector 2, right? So it has two numbers in it. I said pause.x, which means that I am accessing the first variable in that holder. And you can also do pause.y to get the second one. To get the second one. Same thing as R and G. Because you can access a vector 4 by its RGBA values or its XYZW values. It's the same thing. I'll go over that again later. So pause.x, and we want our output to be, well, let me write the rest of it. Float B. So red, green, blue channels. I'm just writing it as RGBs for shorthand. Oh, and I see here that there's this big red block. If I wanted to see what the error is, this is something specific to the force. The second icon from the left, you can click on that, and then you get these little X's that you can mouse over to get your error message. So here it says, cannot convert from int to float. What this means is that I made 0, which is an integer by itself, and I can convert it to a float by just putting a dot. I know that like if you're new to this, all like floating point integer, these are things that'll become bread and butter one day if you continue to pursue this. So anyway, so because the numbers without the dots are integers, we want to make it into a float, which is floating point number, which means that there's just a dot there, which means that I can do like 0.6. So basically, integers are whole numbers, and floating point numbers are whole numbers and everything in between. Anyways, okay, so here, and we want to make our vector 4 out of the RGB channels that we just made. Cool. Oh, great. And now we see that the red channel is, if we were to do y, right? So it's a function of the x component of the position. And think about, you know, high school graphs. The x component is like on the graph. It's the one that goes from left to right, and that's why it's 0 and then 1 on the right. Anyways, so here we see that, well, I want it to move. And so what we're going to do is we're going to use time, which is a built-in global variable, which means that you can use it anywhere. The force gives it to you. It's stored in the variable time, T-I-M-E. But time is the seconds from when you started the program. And if I were to put that in, it would just be way too big, and your colors would just be not from 0 to 1. And that's what we want. We want the colors to always be from 0 to 1 or around there. If you go below 0 or above 0, it just kind of clamps it for you. It doesn't give you an error, which is really nice. So something that you'll see a lot in shaders is sine of time. And then if we want it to be, if we want it to still have like essences from the position x, we want it to add position x somewhere. So here, okay, great. So now we see that it's moving. The band is moving from right to left. That's because sine is oscillating from -1 to 1 as and plus position. Let me make this a little bigger so you can see it. Plus position dot x. So position dot x is plus. It goes from -1 to 1, and that's why we have it changing from across the screen. Great. Okay, so the green channel, we see that it's going to be a function of position dot y because it's these horizontal lines. Let me see how everyone is doing. People are saying do, hey, hi, just heard an echo. Cool. Cool. So we want this to be a function of y, so that we have our green stripes going is a function of going up and down. But we also see that the green stripes are a lot smaller and more frequent. So what you can do here to make the green stripes smaller and more frequent, like think about things in like terms of like, okay, so if I have something that goes from 0 to 1 and I want it to go from 0 to 1 at faster intervals, so if it goes from 0 to 1, but I want it to be 0, 1, 0, 1, 0, 1, 0, 1, we want to multiply that because it's like you multiply it so that it goes from a larger range in a shorter amount of time. So we multiply it by 20, and that's how we get those. So finally for the blue channel, I'm going to say that I'm going to kind of give you like something like a leap of faith, is that to get that ray effect, we're going to use position dot x divided by position dot y. And once you see it, it'll make sense. So something divided by itself is 1. And so that's why when position x equals position dot y along that axis, so think about this as a graph again, it is bright blue. It is the most blue. And then places where on here, like position is -1 and position y is 1, that's going to be that's -1, and that's black. Negative colors are black. And here, the y is negative and the x is positive, and so it's all black. And we see that it has like 2 of these nice ray effects. And if we want that to repeat, I'm going to introduce a new function called modulus. Modulus is very, it's present in a lot of different creative coding software. Basically what it is that given an increasing number or given any number, it'll take it'll return the remainder after dividing that number by the thing you're modding by. So if I were to do mod this by 1, it'll return something that's always from 0 to 1. So basically, like if I were to do like this sine, well, if I were to have this be like, let me just show you what mod time of 1 would look like. Great, so mod time is always increasing, but here we see that as soon as time hits 1, it goes back to 0. So it's like a sawtooth function. I know there's a lot of musicians here. Okay, so anyways, that's what mod is. It's like a clock. Like a clock, time keeps going forward, and the clock will always roll over back to 0 after it hits 24. Anyway, so we just hit our first checkpoint. We have 20 minutes left. The next 2 checkpoints, let's move on to this one. We're probably only going to get to this today, and then I'll show you how to, I'm probably going to take like 10 minutes to code this, and then I'll show you how to going forward, how to do stuff, and make cool shaders. Okay. We have -1 viewers. This is great. So, okay. So the next thing we're going to do, our next goal, is to create this circle. And the circle, I'm going to be using this method called signed distance functions to create the circle. I'm using this method not because it's easy, but because it allows for more growth afterwards. So if you learn this the hard way at first, it'll allow for you to create more shapes easier later on, more interesting shapes, more beautiful things, including 3D. I have a workshop that kind of builds off of this workshop in a week through Codemy. So if you're interested in like learning more about that, go to their website and go to the events and check that out. It kind of builds off of this knowledge. So the signed distance function, we're going to delete all this. We're going to delete all this. So let's just do this. Okay, so we're going to delete all of this thing that we just wrote. So we just have our position again. The signed distance function is a way to create shapes based on your position. So if the only thing that we have as our input is the position of a pixel on a screen, we want to know if we're inside of a shape or outside of a shape, because then we know if we want to color that pixel the color of the shape or not. Again, it's kind of weird to think about shapes this way, because you're starting to think about it like from a pixel's point of view. So they're called signed distance functions because to indicate that you're on the inside of a shape, it will return the distance to the surface of that shape, negative if you're inside the shape and positive if you're outside of the shape. So, so you can do some pretty cool stuff with that metric. So it's like you start describing shapes with distance functions, just basically like math functions. So the signed distance function for a circle, we're about to write that. It has to be above the main function because everything is executed in order. So the main function must know about the circ function before we use it. So much like the types, much like the variables in GLSL, this function needs you to tell it what type it's returning. So float, because it returns a distance, and a distance is just a floating point number. And then it inputs position, which is, or let's just call it P for brevity. And we need to tell it that it's inputting, so yeah, we need to tell it that it's inputting this vector 2. Again, very, very, very typed, very strongly typed. So let's just return 0 and then point. And then let's do, let's have our shape. And then I'm just setting this up so when I finally write it, it'll just appear. Great. And then this is going to be vector 4 of shape. And this is shorthand for for writing shape 4 times. So if you have a vector 4 and you just put one variable, one floating point number in there, it'll know just to populate every single channel with that. And that's specific to floating points. You can do that with vector 3s and vector 2s. So vector 2s, if you put in a floating point number, it'll just propagate that single floating point number across the 2 bins, and vector 3 floating point number, it'll propagate across the bins. It only works for floating point numbers and vex. So the sine distance function for a circle uses a built-in GLSL function called length. And what length is it's much like Pythagoras' theorem. Given an xy position, it'll return the distance from the 0, 0 point. So it uses length, and so it returns the distance to a 0, 0 point. And when I say 0, 0 point, that means the center of the screen. And this circ function just puts the circle in the center of the screen. You'll figure out how to, we'll learn how to move it later on. So we want this circle to have some width. So we use the length function, so return, god damn it. My keyboard died, which is like very unfortunate. Okay, cool. So we see that it returns a low number in the center and black at the very center, and then it kind of has the distance kind of fade off because it gets farther and farther away. So it starts returning the distance greater and greater until we get 1 right here, and then it goes into like positive maybe like 2 over here or something. But we want our circle to have some width. And so what we're going to do is that we're going to subtract the radius. And then r equals 0.3, whatever, 0.2. And so now our circle has a radius of 0.2. So basically that means it takes a length function, and then it gets the distance between this, and then it subtracts 0.2. So it's like it goes from here to the length, and then it subtracts that. And then you get your surface is 0 out here and negative numbers in here. So it's my whole thing about sine distance function, which is just kind of swell and come to that. So cool. So now we have our circle. We're working on the view count bug. Oh yeah, sorry about that. I really like having negative 12 viewers. It's pretty empowering, to be honest. It's like I get to just embrace the absurdity of my life, of you know, I just like that concept. And also, like, this is so cool to begin with, and I'm so happy to be here. I really don't want to come off as I'm complaining about it, because I honestly think that this is really cool, and I'm honestly so excited that I get to like share the thing that I love doing with something that I love, which is MUTEK. It's been a huge inspiration of mine to be able to perform for MUTEK, and I even like had it as like a goal of mine to be able to perform for MUTEK. And thank you. And being able to teach this workshop I'm beyond thrilled. If I'm doing my best to like not be like freaking out right now. Am I right? Yeah, because we got some math to learn. So anyways, so now we have our circle. Finally, let's add some color. So if we look at the checkpoint code, we see that the color is coming from this cosine palette function. And at first, and I'm going to go through this really quickly because I only have 13 minutes, but basically I'm going to tell you exactly what it is. So cosine palette is a way to, it's a very beautiful, simple function to be able to have control over your palette, because so many times when you're trying to create color with code, you're kind of stuck in this rut of trying to think of red channel, green channel, blue channel. It hurts after a while. This is a way to create a color based on the brightness, contrast, oscillations through cosine, and the phase of cosine. So I made a on the workshop page. If you go to the tools, you'll see here's the cosine function graphed out, and so I have the cosine palette function graphed here. You'll see that I have the red line graphed to the red channel, green line graphs for the green channel, and blue line graphs for the blue channel. And so here we see that there are, like, for example, like if you give the cosine palette input of time, when time is equal to 8, it could be input to anything. It could be like input of position across your screen. It could be input to your circle function, 8. So 8 here, it'll have a lot of green. It'll have less blue, and even it'll have no red because red actually dips below blue. So it'll be this kind of like very teal-y color here. And then that will, as time goes on, it'll fade, and then it'll be less blue and it'll be even more red. And at this point, it'll be this kind of like greeny, like pink and green. I don't even know what that is. I'm sorry, red and green. And here, okay, so anyways, I want to show you the different parts of the cosine palette do. The A part of the cosine palette function controls its brightness. You could imagine this is just making the red bright. So here it's like it's red a lot. Here it's not that red. Okay. B will change the contrast. C will change the frequency at which it changes, the oscillations, and then D will control the phase. Cool. Now we know that. I'm going to go ahead and copy and paste the sine distance function in because we don't have a lot of time. I'm sorry. I'm going to copy and paste the cosine palette function because we don't have a lot of time here. And I wish I could put it in the chat. I can put it in my Twitch chat. Oh, unrecognized comment. Unrecognized command? I can write commands? That's insane. Okay, that's crazy. Anyways, I discovered something in Twitch. Okay, so I'm going to copy and paste that in. Aman, if you could paste that in the other chat, that would be cool. But if not, that's fine. You can come back to it later. So let's put it before main. Now we have, and I have the credit as to where I got it from. Inigo Quiles. And here's the cosine palette. So I'm also going to copy and paste in the how I use it, because no, I don't want to do this. I'm going to write it out. Okay. So we have vec3 brightness equals vec3 of 0.2. I know from experience that doesn't look very good much as a higher number. So, and then this will be like 0.4. That looks good. vec3 oscillations, and then this will equal 0.3, well, 0.3, equal vec3, phase equals vec3, excuse me, 0.3, okay, whatever. And then now we're going to have our cosine palette. We're going to use our cosine palette when it's going to turn to vector 3, which is a color RGB. I know color, yeah, whatever. Okay, and let's call this call equals, and then we're going to input, I'm gonna fast track you. And at first I always input time, but I know it looks cooler. Oh my gosh. If you do time plus, what the heck? Okay. Okay. Oh my gosh. This is cursed. Okay, I guess I can't do that. Okay. Cosine palette, and then we're going to do time plus shape, and then we're going to say brightness, contrast, oscillation, phase. And it got an error. Oh, I spelled it wrong up here. Okay. Oh my god. I was typing that so fast. Okay, cool. So let's have our color be instead of the shape. Okay, cool. Now we have our beautiful circle. We finished the checkpoint. We have 7 minutes left for me to explain the rest of the material that I have presented to you, that I have on the link, so you can go off and like make your own shaders and stuff like that. So if we go back into charstiles.com/livecode, we see, oh yeah, in the graphing calculator I just linked, it's just basically this, like it's just desmos.com. It's great for this kind of stuff. Leave. Okay, so code we have for, and then this is if you wanted to understand more of like how this works, I recommend you check these out. And then the thing I really wanted to go over is this thing I made called a sticker sheet. A sticker sheet is it's a bunch of functions that you can copy and paste in and then use to make whatever you want. And so, for example, this is HSV to RGB, which is, it works like the Cosine Palette in that it returns a color. Your input is a hue, saturation, vibrance input. Actually, I think this is built into the force. Anyways, and then you have different shapes here. So like I said, the sine distance function is really great because now you understand how to use this really complicated triangle function. You just know that it returns negative on the inside of the triangle, 1 at the surface of the triangle, and positive number at the outside of the triangle. That's all you need to know to use it. You don't need to understand all this math. Pentagon function, cross function, you can use it to make x's. Cosine palette function is here again. And then these are modifying space. I recommend you, these are really like very rewarding if you use them. Something I really wanted to go over because this, I know a lot of you probably want to know how to create visuals for this, is how to input your microphone into the force. How you do that is if you go here to this question mark and you go to uniforms, you'll see that there's this variable, this global variable called bands. And it passes in a vector 4 of the low frequencies, the mid to low frequencies, the mid to high frequencies, and the high frequency fast Fourier transform results. Basically, it's just binning the frequencies of a sound. How you get sound in is using the bands function, but you can also, someone texted me. There's also, so if you click this microphone right here, and you go to mic line in, you can click this button right here. So again, it's the second icon, the first icon from the bottom, you click it and it opens up this window. Audio in and mic line, and you start here and ask for permissions, but because I already gave it permissions, it'll just start working. And then you can just start using bands the same way that you use like vector 2. So let's do the contrast. So here, bands is a vector 4. So if I wanted to make it a vector 3, I can access the first 3 variables. So bands dot, I would love to ask if this was like an IRL workshop, I'd be like, how do you think I do it? But alas, dot XYZ. Great. And now, when I talk, the contrast increases. So you can use this in any way you want. So you can also create, like if you want your circle to get bigger as things get louder, you can also put bands.x here. So now the circle's getting bigger as I talk. Cool. Other thing, 56, so that's how you get your audio input. I wanted to also go over how you can get your camera input. And how you do that is if you go under 2 hours. I get 2 hours? Oh my gosh. I get a whole nother hour. That's so exciting. Okay. Oh, yeah. Oh, this is going to be so good. Okay, yeah, because I was like rushing through it and I was like, we're not going to get to any of the cool stuff. Yeah, that's right. We're going to get through so much shaders. Oh, yeah. Oh, it's so exciting. Is anyone, so now we're here for another hour. Does anyone have any questions? Ah. Sick. Okay, cool. So, okay, so how you get your webcam input is you click this slot. So if you mouse over, you'll see it'll say texture channel 0. And then you click this webcam right here. And then it'll ask you, and then it'll give you an error because you're using your webcam to stream to MUTEK, but if you're not, that won't work. Let me see if I can, I'm gonna do something really stupid right now. Camera, and let's use this camera. And then can I save this? Let's see. I'm just going to refresh and see if this turns out. And so let's do the audio first. I just refresh. Ooh. And then here, let's do our texture 0. Did it work? Oh yeah, okay, cool, it's working. So if you want to get your webcam input so you can make a computational selfie, you can go, so how you can get other textures, I'm going to stop this because this is really annoying. Okay, so how you get other textures is you get, like how you can get like a texture buffer into a shader is you use this built-in function that belongs to GLSL, not the 4. It's called texture2D. And it returns a vector 4. Again, vector 4, RGBA. Cool, so vec4, or let's call this web for webcam, short for webcam, equals, and then we're using our texture2D function. And then I know this because I looked, this isn't like actually documented in this question mark window because, like I said, this is open source, i.e. this is made by one guy in his spare time. I think it's just really nice to have this for everyone, and I really want to contribute myself because I've been using this to show in the workshops. I'm collaborating on my own shader editor, and I know how hard it is to create all these different inputs. Anyways, that's beside the point. So texture2D. And we get in our back buffer, and I know this, like I said, I know this because I looked at the code, I looked at the GitHub repo, which is where the code lives. And then we're going to get in the UVN, which is the normalized UV coordinates. And so usually for graphics programs, it'll assume that the bottom left corner is 0, 0, and the top right corner is 1, 1. The reason why UV in the 4s returns 0, 0 in the middle is just because for making graphics, it's easier, for making shapes and stuff like that, it's easier to think about it with the 0, 0 in the middle. But if you're accessing like a buffer of sorts, you need that coordinate to be 0, 0 in the left-hand corner because that's what it's assuming. So now we have our webcam, and ready, and prepare yourself to see me. No, it didn't work. Oh, because it's a vector 4. Okay, hello. Oh no, it didn't work. Oh right, because I used back buffer. How silly of me. I started telling you about something that you're probably really confused. It's called channel 0. Okay, ignore back buffer. I'll go over that in a second. So this is me getting my webcam input. And I can do the same thing that I did with the circle, with the, you remember how I transformed the UV, how I transformed the position in the previous shader by adding sine of time plus the position of x. So I can do that here too. And then it goes crazy. And I want to multiply this by 0.02. So I just scale it down. So it just does that. And then I want this to be also pos.x. And so I have this kind of like, so now you remember how, now the webcam is being distorted through a function of the x position across the screen, and that's why it's having this stretching and pulling effect. Okay, so the next thing I want to show you that's really cool is I want to show you the back buffer. I could just turn this off now. Oops, not this one. What is this one? Like, now you don't even need me in the corner. So basically, I want to also show you the back buffer. What that means is that it is it saves the previous frame in a buffer for you to use. So it's like, so a downside of coding shaders is that you never know what your neighbors are doing. like as from the perspective of a pixel, you don't know what the neighbor next to you is doing, because all of this function is being run parallel using. That's why when you hear people talk about GPUs or graphics processing unit, they'll talk about like parallelism and stuff like that. So it's a downside of shaders that you can't like check up on your neighbor next to you, be like, hey, what did you do? Or like assume that there's going to be any order to the pixels being rendered, because you don't know that. You can't assume that in shader writing. So what we're going to do here is if we want to access the previous buffer, we can do that. So one single frame before us, we can see everything, because again, like that was rendered. We know that was rendered before the single frame that we're rendering right now. So cool thing to do with the back buffer is to have a threshold of a color. So when I say threshold, I mean like kind of like an if statement. And so let's say like if, and I'm going to do something crazy. So if web.r, so if the red channel of the webcam input, like my face is very red, is greater than, or let's say less than, let's have the dark colors be this, less than 0.2, let's have col equal, let's do the same thing we did before to access the back buffer. And again, I know this because I looked at the code of the force 2D, back buffer, and then UVN, great. Oh, and col, and we need this to be an XYZ dot, or RGB. XYZ and RGB are the same thing. What does it want? It gives me an error. Let's see. Col undeclared identifier. Oh, because I declare it right here. So let's put this up here. So do that, and then we want our frag color to be vec4 of col. Oh, because I put that inside of the if statement, my bad. It's good to see me mess up. Okay, cool. So now we see, let me make this a little bit, is less than 1, or, oh, let's say greater than. All right, hi. Okay, cool. So now we have my face, and let's make a col equal, let's have this be, well, so, okay, so basically, I'm gonna make col equal the webcam. Okay, because that just makes more sense. Okay, cool. So basically we have it rendering the color equals webcam. We're not even using this cosine palette function at this point. So col equals the webcam colors, RGB, and then I say if the, and I'm going to make this, I'm going to make this less crazy. Cool. Okay, so, and I'm also going to increase the pixel resolution. Okay, so we say if the color is greater than 0.8, I'm actually going to make this less than 0.8. Cool. So I'm just thresholding it. I'm going to make this 0.5. Cool. I have that the color is equal to the previous texture. So basically the, like my black shirt is acting like a green screen, and it's just kind of getting the previous, whatever the pixel was in the previous frame, that's what it's going to be. A really cool effect that you can do is if you want to kind of have this like a trailing effect, you can change the position at which you grab the pixels. So I really wish I had a green screen. So if I wanted to do plus vector 2 of 0.0012, and we see that now it's grabbing the pixels that are 0.002 to the left of it. Sorry, anyways, this pixel would be grabbing the pixel that's beneath it. Okay. Cool. Okay. So that's awesome. Let me. So now that I showed you some cool stuff, I'm gonna show you. I'm going to get back on track. So I just showed you some extra stuff, which I actually have listed. If you go to the charstiles.com/livecoding, it's the last link. Oh, gosh, I guess it's not there, but I have it here. So webcam back buffer final to 4. So I have that here. I'll just paste it in the chat, and I'll link it there later. Okay. All right. So up next, I'm gonna get back on track on what the Livecode website says we're gonna do. I'm gonna show you next. I'm gonna show you how to transform your objects, and I'm gonna show you how to add more objects to it. So you see here, like there's this square, and we see here that this is moving and it's also being repeated. I mentioned that there is a space modulus operator. That is what we're going to be using. Cool. So while this is all happening, I'm gonna give a moment to digest everything since we got through the first checkpoints plus this extra fun stuff. I'm gonna give a moment to digest, and I'm gonna go over some inspiration, some examples of things that I like. Okay, so if I'm gonna show you 3 examples of some really cool shader work. So this example is made by an artist named Sol Saratia. She's a mathematician, also computational artist. She's also a painter. And I taught this workshop to her, and she, like, within one day, she kind of came back and was like, hey, I created this 3D fractal using shaders. I was like, whoa. And she put up all the code online, so you can go to the website, right? You can go to her website and you can see the different 3D shaders, the different, like, so this is a GLSL shader that she made, and you can rotate this 3D shader. You can change the power of the fractal, and you know, everyone knows what a fractal is. Basically, like, this is it has to do with, like, yeah, I don't know, it's she just did a really nice job of being able to control it and stuff like that. And this is one example of that. She made this, and it wasn't this workshop after she did it. It was specifically the ray marching workshop, which is the workshop that is after this one. It's going to be next weekend, presented by Codemy. It's on their website. I have the website's kind of up here. You can kind of go to their website and then go to their events workshop. And yeah, and the next inspiration I want to show you is this amazing editor called Shader Booth. Is this going to allow me to do it? Oh, wait, why am I tiny in the corner? That's weird. Anyways, so Shader Booth, I don't know why I'm so tiny. It must be because I'm using my webcam for all sorts of stuff. Basically, it allows you to live code your face. Oh, there we go. Oh, so cool. All right. Okay, so we see here that it passes in. So it's like, it's very similar to the force. I should just teach the workshop in this. It's just so cool. And then we have our, this face center is very similar to how like the back buffer and like other global variables work in the force. So it's just passed into you, so you can use it for whatever you want. And this kind of gives you a really nice, oh my gosh, it really gives you a really nice example. Like, okay, here we see that there's, like, you get the eye, so get eye is a function that Max will give you, and then you can use get previous. Oh, okay, so it gets the previous eye, so there's probably like a 1 frame delay from these eyes to my eyes in the middle. Oh, very cool. Oh, that's super cool. Yeah, that's like a old photo booth in Mac. Whoa. All right. Very cool. Shader Booth is awesome. And the last kind of like shader inspiration, I wanted to show you I don't know this person, so I know those two people personally, and Max was actually one of the TAs for the last workshop. He did a wonderful job. And I want to show you this shader. You can simulate a computer from, I wish I knew the year, Apple I, 1980s? 1984? So you can simulate a computer from like the 80s and the 90s in a single shader. I'm not exactly quite sure how this happens, but it's pretty freaking crazy. And I have it right here, and my computer's not going to like it that I just clicked on it. Whatever. Actually, it's not going to load it. Okay. Okay, maybe I shouldn't have done that. Eee! Well, anyways, so while that loads for a little bit, all of these are very creative uses of shaders. I'm sure that like in your life you have Okay, cool. So in your life you've come across some really awesome examples of shaders being used in real-time performances or real-time graphics performances. But those are just like three very unique examples that I came across. Okay, so let's get into the next phase of our workshop is to repeat the space. So we're going to start working towards the second checkpoint. So if you're following along by copying and pasting the code, go ahead. And if you're just joining us from, if you joined us like however many minutes ago, if you go to charstiles.com/livecode, you can see the code examples of what we're going to be writing. So I recommend if you just joined us, go to the second checkpoint and then copy and paste this code into the editor that we're using, which is the first link under the link section, the force. If you copy and paste that in, you'll see something like this. And that's what I'm going to be writing. I'm going to be writing that shader. So you can see the finished code, and then you can see how I get there. And if you're teaching workshops ever in quarantine, I really recommend you do things like this, because I don't expect anyone to have a very long attention span. And so redundancy is so important for this kind of work. To expect people to be able to follow along me just writing code would be unfair, so I have these checkpoints. Anyways, so we see that it's our circles moving across space. So let's, I think, I'm going to make col not equal webcam RGB, and I'm just going to work it with it like this. So you can see our circle, but then you can also kind of see me. No, I think this is confusing. I think I'll just comment out this code. And when I say comment out, I mean I'm going to highlight it and then press Control /. Then it comments out the code. So now these are all comments, which means that they're just not executed. All right, so exciting time. So like I said, also if you're just joining us, I just want to say that like this is so cool that this is happening. I'm so excited about a lot of the different sets that are happening. I'm a huge fan of Jasmine Infinity and Qualiatic, and the fact that I'm like in the same festival as them brings me joy. So I'm really excited that this is happening and stuff like that. Okay, so the next thing we need to do to create this, to repeat space, is to use the modulus function again. And before we get into that, I need to make a point that this is something that is unique to shader programming, in that you can, with very little extra computation, you can repeat objects in space. That is very different from other graphics programming languages, such as, for example, like processing. In processing, if you have many objects and you keep drawing them over and over again, that's going to be a lot more work on your computer. for this, we're just going to be using the mod function. It's a beautiful part of using math to your advantage here. So the modulus function, I'm going to write it out because we have 2 hours here. So the mod2 function, so that's what it does is that it will modify the position on the screen. Again, like I said this earlier before, the input of your shader is going to be position and the output is color. Because we only have the position to work with, that's the only way that we can control the shapes in our code. For example, if I wanted to move my circle to the right, I would have to modify the position before I call the circle function, because the circ function, no matter what, will always draw the circle at the 0, 0 point. There's no way to say, hey, circle, move to the left. Change your left component to 0 plus 0, 1. This is very counterintuitive to the way that we think, but it, like I said, it kind of allows for other forms of expression in shapes and colors and stuff like that. So here in the shape, before we call shape using position, we're going to modify position. And we can redefine it just like this. A lot of programs don't allow you to do this. In this program you can. You can redefine functions and then things will happen very much like in order. So if I modify it here, it'll only change for that line and then the lines after it. Pos equals pos plus vec 2 0.3 0. So I just moved it to the left a little bit. And that doesn't really make any sense. Usually in programs, when you want to move things to the left, especially in a coordinate system with -1 on the left and 1 on the right, you'd think that you'd subtract things because you want it to be moving to the left. But here we add it because the only thing that we control is our pixel position. Much like in life, the only thing that we can control is ourselves. In shaders, the only thing that we can control is our position. Is the perspective from where we're coming to drawing the shapes. So if I want to move it over more, make that number bigger. I want to move it over less, make that number smaller. I'm going to make it a little bigger. Cool, so that's how you move things around. I'm actually going to delete this because that doesn't help us for when we want to modify the space. How we modify the space, remember the modulus function? Okay, it's going to be in a function that returns, let's see, well, I'm not going to write it out. I'm going to copy and paste it because I think that is easier, or that's better for us right now. So that is mod 2. So here, the reason I wanted to write it out, well, I'm going to write it out because I think it's kind of cool. Okay, so it's not going to return anything. And then p mod 2, because it mods in 2 dimensions. It takes in, I'm going to say in out, and I'm going to use this new variable, in out p, and it's a vector 2. And then what this means is that in out means that it will modify p in place. And so you see that p mod 2 isn't returning anything. So what we're going to do is that we're just going to call p mod 2 on a vector 2 position, and then it'll change that, and then everything after the p mod 2 is executed will be modified. So here, and we're also going to need a vector 2 size. And then here we're going to p equals mod function, and then we're going to say mod p by size, and then we're going to subtract Or let's just see what that looks like. Because before I give you the answer. So p mod 2, and then we're going to want, oops, we're going to want the position in here, pause, and we want the size. And so let's call this, and then let's declare a size, or vec2, vec2, 0.2, okay, cool, okay. Let's make it a little bigger because right now it's just too big for us. Okay, cool. So now we see that it's being we see a fourth of the circle repeated in every single direction, in the x and the y direction. If we wanted it to repeat only in the x direction, we would just make the x1 and the y0. But if we wanted to repeat this space with 0, 0 being in the center, what we're going to do is that we're going to subtract size times 0.5. So we're going to subtract half of size. And so then we get this nice, that actually looks really nice. And we get with the circles in the center for every single space that is modded. Okay. All right. And the stuff that's here in the other PMod2, so you might notice that there's like this line here that's different than what I just wrote. And it does actually return something here. Basically what this is, we don't need it for this because we're not going to use it. Or can we? I'm going to stick to the code that I have here. But what this can be used for is it's an identifier for every single space. So this space, this like pod would return a different number than this one, then this one, this one, and then they could all be different colors. However I wanted to use it, they could be all different sizes or anything like that. So, okay, cool. So now we kind of have this. Well, let's make it closer to that. So if we wanted to make it closer to that, we would make our size 1, 1, so that it looks like this. You see that there's many circles there. And then we want it to move. We can say pause equals vector2 plus, well, it's moving to the side to the left, so we just have this be time. Cool. Great. Now it looks like that checkpoint, except it's moving the opposite way. It's moving to the right, ours is moving to the left. But we know how to change that. We know that we can change directions by just subtracting instead of adding. Great. Oh my god, Jasmine Infinity's here? What? I just gave her a shout out and now she's here. I did visuals for her in Hot Mess like a really long time ago, and it was such an amazing set, but it was also like it was a really fun time. Anyways, hi Jasmine. So anyways, next thing we want to do is you see we have our next thing we want to do is we want to add this square. That's the whole point of this, and that deserves its own checkpoint because it's a pretty important point of like how do you combine shapes. I am gonna copy and paste the square function. I know I have avoided copy and pasting functions in, except for the cosine palette function. Yeah, I copied and pasted that in. But okay, yeah, take back everything I said. Anyways, so I wanted to, let's go to the sticker sheet. So for people who are joining us, basically the format of this workshop is that I have all of these checkpoints so that you can copy and paste the code into this editor that we're using, Online Editor, no downloads. It's available and free. Online Editor by Sean Lawson, and that is linked. So this big link up here, right up here, this will link you to everything. It's like the link tree. The Force by Sean Lawson is the first thing under links here. And if you click that, it'll just kind of open up a window that looks like this without all the code. And then you can copy, you can go to any of the checkpoints, you know, if you wanted to go back and look at them. So right now we're about to write this checkpoint, so I recommend if you're just joining us, you grab this code, so you open that in a new tab, and then you can hit raw, and then you don't have to hit raw, but you can if you want. So you just Command A, Command C, or you can do it the good old this way. That's right. Give our brains a little rest. Yeah, just watch that scroll by. Control C here. And then you go into the force, and then you can Control A, Control V. I'm not going to do it because I'm going to write it, but that's how you can do that. I don't know why I explained that. I guess it's because I have like a mushy brain, and I would want that to be explained to me at this point. Anyways, so let's start creating our box. Let's get the box code. The box code is, if you go under Tools, the first link, I have something called a sticker sheet. It's basically just a bunch of functions that you can copy and paste in. We just wrote this circle function, but it's here in case you want to use it for other stuff. The SD box function is this right here. So it's underneath the circle function on line 23 in the sticker sheet code. You can copy it, and then you go into here, and you have to put the box code before you use it. So it can go anywhere. It can't go inside of one of the functions. It can go above or below. So I'm going to put it on line 6, and I'm just going to Command B right there. Cool. We see that in Vec2, we can actually delete this. It really doesn't even matter. I know like a lot of people get confused about the in. The in just specifies that it's it's just an input variable. I'm sure there's a reason why it's there, but it doesn't really matter. You just, for the purposes of this workshop, just know that this is a variable that you get passed in. Cool. So the SD box function can be used exactly like the way that the circle function was used. So let's create a float. So under our main function, where all the code is being executed, the main function, let's say after we declare the circle function, let's create a shape2, float shape2 equals SD box, and then the input is position, and then you need a vector 2 to declare the size of each of the boxes. So let's do 0. Let's make it really small. Cool, there's our box, small box. And if we want to look at just our box, we could just say here, I don't know why I'm doing this, shape 2. So there's our box. Very simple. But if we wanted to have our box and our circle at the same time, let's have our box be moving back and forth. And let's also have our box be oh, oops. That's funny. Okay. Ignore everything that just happened. Okay. 0.2. Okay, cool. So it's going to be our box. We see here that the box also has like a hard outline. And how we do that, we're going to use the clamp function. Okay, so our shape 2 is this, and I actually want to clamp the box before I start moving it around. Before I add it to the circle, I want to be able to look at it. So we have our box. Oh no, I just called it shape 2. Okay, so there's our box. And I want to clamp the box so that it has a hard edge instead of this smooth distance. And so how you do that is you say shape 2, you can redeclare it, equals clamp. Where's the clamp? It would be sealing, which stands for, so if you have like a floating point number, or a number that's between like two whole numbers, so for example 0.5 is a floating point number, and you want it to become a whole number, you have 3 options. You can floor it, which means you bring it down to the number that's below it, like 0.5 would be floored to 0. You can ceiling it, which bring it to the number that's above it, which would bring 0.5 to 1, or you can round it. And so 0.5 would be rounded, I think that would be rounded down. I'm actually not sure, I should know this, but I don't. So like 0.4 would be rounded to 0, and 0.6 would be rounded to 1. So seal, so we just want to seal our shape 2. There we go. So now I have a hard edge on our circle. So because, on our square. So just to reiterate, the SDBox function stands for Sine Distance Function. Sine Distance uses distance to create shapes. And a sine distance function will return 0 when the pixel is at the surface of the shape, a negative number when the pixel is inside of the shape, and a positive number corresponding to the distance of the pixel from the surface of the shape when it's outside of the shape. Other things I want to do, I'm actually going to move, this is kind of getting a little too, I know it's like, actually going to just slow this down a little bit. I kind of got sick of it moving really fast. Okay. In our checkpoint shader, we see that the box is moving, kind of oscillating. So that kind of signals to us that we're going to be using a sine. And it's moving independent of the circle. So it's kind of moving side to side without the circle. So before we declare shape 2, I'm going to use, I'm going to modify the position again because, like I said before, the only thing that we can change is the position. We can't change the circle. We can't change the shapes, like as object-oriented programming leads you to believe. So what we're going to do now is we're going to redefine position equals pos plus vec2, and then we're going to move it side to side. And so the x value, so again, this is like a coordinate system. The y value corresponds to the pixel's height, and the x value corresponds to the pixel's width, or rather its position along the y-axis and the position along the x-axis. Vector 2 of sine of time. And we want the semicolon, and we see that it's probably going to be moving crazy outside of the screen. And so what we want to do is we want to scale it down so that we scale it by 0.2. Okay, cool. Now we see that that's moving up and down. And we just want to move it so it doesn't move up. We just want to move it so that it moves side to side. So just 1, 0. Cool. And now we see, that's funny. Okay. The reason why it's like moving and then stopping is because of this. Because we're moving the position. So if we were to stop this, comment that out, we'd see that it would be moving back and forth. Cool. I'm going to make my square smaller because I want it to, well, it's a little bigger. And okay, cool. It's a great size. And now we want to combine it with our circle. How we're going to do that is I'm going to tell a story, everything in the perspective of the pixel. So this, like writing shaders, is like writing stories from the perspective of the pixel. So if you're a pixel and you have a distance to a sphere on the screen and a distance to the square on the screen, how are you going to choose to use which one will color you, right? You're going to want to choose whichever one is closer to you, because if you're a pixel and you have, and the math turns out that you have like a square right on top of you, you're going to want to be colored based on that square. So what we're going to do is we're going to combine the circle and the square by using a min function, which is built into GLSL. Again, if you have questions about like what functions belong to GLSL and what functions belong to the force and what functions belong that we wrote, feel free to ask them in the chat. Oh, right. So the code, everything that you can find is up here, charstiles.com/livecode. And this is the webpage. Right now, we're about to start embarking on the final checkpoint. And so what I recommend is that you click on this code right here, you open a new tab, and then you just copy and paste all of this code into the force, which is this online editor that we're using, which is linked on top of links. Again, like this is charstiles.com/livecode is the link tree, and this is the editor that we're using. Up here, and you click on that and it'll bring you to something that looks like this, and then you can just copy the paste right in, and then copy the paste right in, copy the code right in. Great. Okay, cool. So we want to combine the two shapes. So I was just talking about the min function. So we want to redefine our shape equals min of shape, which is our circle, and shape 2, which is our sphere. And it didn't change anything because I still have this being shape 2, but if we were to have this be shape, we would see that our circle, which is being controlled by our audio, this I'll go over later. I'm going to remove that for now, just because it'll be confusing for people that just walked in. Cool. Now we have our soft circle with our hard. This is so it's so yeah, with our square. Cool. And if we want this to be colored based on the time and the shape, code that we wrote before, which is just sets the cosine palette to be dependent upon the time and the shape, we can just use that right here. So we already have that built in because we already used shape. We redefined shape so we can use it the same way before. Okay, cool. Oh, cool. Look at our square and our circle getting along just fine. You can't really see the square, but it's there. So basically I just really wanted to show you how you can combine two different shapes. I know this isn't a very compelling example. Let me make the square bigger. Okay, cool. Yeah, there we go. Great. Now we have 20 minutes left. I'm going to freestyle for a little bit and explain everything I do while I do it. And I'll upload the code to the website after I'm done. Any questions before we start to kind of like freestyle and like kind of do different stuff with shaders and explain kind of like now that we got the fundamentals done, I'm going to show you like some like cool fun stuff that I like. Any questions before I do that? Okay, cool. I just had to give my brain a rest. Okay, so some functions that I really like in the sticker sheet, I'll like point out. I really like this mmod polar function. So I'm going to copy and paste that in because it kind of creates like, it's basically like a kaleidoscope function. And it's really nice. Oh, I have to define. Oh, right. I really should fix this. But basically, whenever you use floating point numbers in the force, this version of GLSL requires you that you put a dot after the number to indicate that it's a floating point number, because otherwise it assumes that it's a whole number, an integer, and it tries to multiply like an integer with a floating point number, and those two types aren't the same, and so it can't do it. So it complains there is an error. So anyways, how do we use this mmod polar function? We see that just like the mmod function, there's an in-out vec2 and then float repetitions. Let's just go for it and see, play around with it. So, so before we call our shape here, after we mod 2, let's do mod polar, and then our position, and then how many repetitions. Let's say 8 because it's a good number. Oh, cool. Check that out. So basically, the only thing that it really affected was the square. Is it made it into an octagon because it would repeat it 8 times. So let's see what happens when we put it before we mod the space. Oops. What happens here is it'll mod the whole thing by 8. And I'm going to keep this because I like it better. And then we can change this. We can change this to like 1. Okay, there's nothing. 2, we see that it's like mirrored, but you can't really tell the difference. 4, 3, you see that it's being broken off into 3 quadrants. 4, there's nothing because it's already pretty symmetrical, and 4, 5 becomes pentagon, and then so I like 8 a lot. Cool. Great. So I really like that function because it's just really, really rewarding, and given the inputs. Other things I want to any questions so far? If you're trying to do something, trying to I really want to try to do this. Write it in the chat, and it'll be a cool way to introduce some more functions. So there's so much content. This is just really scratching the surface of what you can do with shaders. So I kind of assume now that I'm going to go over again how I'm going to get the webcam and did I delete that? No, the webcam's right here. So I'm going to start getting my webcam input as a texture. So just to reiterate again, I got the webcam texture input by clicking the third button from the bottom, opening that up, clicking the channel 0 here, and then clicking the webcam as the input. I know that's like really counterintuitive. Like you want to just be able to like 9 cat. Like I want that to be there. I want that to be. But you have to click the channel, what you're going to use, and then you have to click the thing that you're going to use. So if I wanted to have like webcam and like if I wanted to have like the audio in the second channel, I would click that and then I would see that. So to show you what the audio looks like, you might be interested. It's different than the bands variable that we went over before. This is going to be passed in as a texture. And so you can actually see that right here. So let's do that. And so this is a function that's built into GLSL texture. I'm going to comment at the end of the code. And then I'm going to say, so I just put it in channel 1. And I just know that channel 1, UVM, cool. Okay, cool. So now we have our audio input as a image, which is really, really cool. Again, so how I did that is the texture one, so I moused over and I saw that it was channel 1, and I just know this from experience. I wouldn't expect anyone coming into this would know, and now you know because I'm telling you, and I hope that if it appears a question about that, can I help them? So I got the audio by clicking on the output buffer that I want, and then clicking on that. Again, I can change that to be my keyboard. I wonder, oh yeah, there we go. So I just if I hit Q, you see that something lights up. If I want this to be the out, so if I want this to be the output, I can do that. Hopefully this is making some sense. Okay, cool. Yeah, so that's how you choose the output. So, but I don't want anything in texture 2. So, anyways, that's how I got the webcam input. And here I'm saying col equals web RGB. This is something that I wrote before. I'm going to uncomment it again. Web col equals web.rgb. I'm actually going to say no to that. And so here I'm not redefining col, but I'm still using web as the thing to create the condition on. So it uses the back buffer, which is the previous frame, nudged over a little bit if the webcam is dark. So that's why the places where like my sleeve where it's dark, it kind of creates this like tunneling effect. It's just like a really, really, really simple way to get kind of glitchy, cool looking code. A really quick way. So for people, we have 10 minutes left, unfortunately, but just to kind of reiterate some of the things that we learned today, it's that shaders are powerful programs that are run 1 time per pixel, 60 times a second, so it comes out to being run 100 million times a second. I'm going to say that again. This program is being run 100 million times a second. It's only 73 lines of code, and it's running at 60 frames a second right here, so it's pretty smooth. It's a really, really powerful way to create graphics. right now we went over how to create colors using the Cosine Palette function. We went over how we can access our webcam. We went over how we can modulate the space, and how we can create shapes. I have another workshop and the reason why I'm here is because Codemy asked me to. They're putting together like a lot of the content for MUTEK, which is really amazing. And they asked me to. I've been teaching this workshop through Codemy for a little bit, and they asked me if I could teach this workshop for them. In MUTEK, as they're kind of the content providers for that. But I wanted to Codemy.com. So Codemy, let's see. They build art and tech projects and nonprofit events to inspire through experience. Very awesome. Thank you to Bruno and Jordan and Ruby and the Codemy team for helping put all this together. The shader workshop I just went through, it has a second part. So if you're interested in learning more, the second part is going to be the fundamentals of 3D shaders. And so a lot of the cool stuff that I showed you before, like Soul's fractal work, that is done using 3D shaders. Some other really cool stuff on 3D shader work, I use a lot of it on my Instagram. A lot of like a lot of, I wonder if I have anything. Oh, well, yeah. So I'm like trying to think about the last 10 minutes of this workshop. Yeah, and then after that, so after the fundamentals of 3D shaders, we kind of go experiments in 3D shaders. Oh, I can actually just show you the web page. So this is basically like the workshop stuff, and we're gonna basically end up coding this in just the force. We end up coding this like 3D space that you can kind of look around in, and so that's in 2 weeks. The one that's next week. Oh no. May March is this workshop. So in this workshop, we learn how to create a 3D scene that we can kind of just go forward, and we don't go through like lighting or anything like that, but you can use all of the stuff that you learned here today. So I'm going to actually show you what that would look like in the force. And I wonder if I can just do it here. Okay, cool. So now we have here, but you can also do like the same way that we did like the cosine palette stuff here. You can do that in using that. So if I wanted to do that, let's do. Oh well. If I want to do that. It gets really loopy once you start using like the cosine palette in 3D. And then I'm just going to throw in some numbers here. Vec3 of 0.2, 0.3, 0.2, or okay, cool. And then we need this to be like, let's call this, oh, I guess that wouldn't really work. My head is like completely mush right now. Okay. Right. Okay, cool. So here we have like our colors are based on the cosine palette, and I can do like last time. Oh, cool. Now we have this like very cool 3D effect, and we can can go through time. So now we're moving in through 3D space. Anyway, so that's an example of something that you can do in 3D. That's for anything that you want really. Anyways, I only have 7 minutes left. Any other questions so far? Yes. Oh, Jordan says they're looking for more workshops as well. If so, Codemy has a submission that you can submit to teach other workshops. So if you have something that you're excited about and you want to share your excitement, you can submit that. You can submit that to Codemy through the link that Jordan might put in the Twitch. And I'm super excited about anything that you might make. I love seeing everything that anyone makes. I'm very open to helping you with the different ways that you can incorporate shaders in your work. I have the example that we just went through, or a version of that, ready to be used in Touch Designer. So feel free to reach out to me. I'm Char Stiles on Instagram and Twitter. I can provide that to you. I also use open frameworks a lot and P5.js, and I don't really use processing, but I can try to help with that. So if you have any if you're like, hey, I have this idea for a project, but I don't really know how to get started, or I made this and Jordan put the link. Oops, /. Oh yeah, so I love to see everything that you make. So if you make anything, feel free to tag me and tag Codemy, because they're the reason why I'm here, and tag MUTEK so they know that this was a good workshop. And also if you want any feedback on anything, and even if you're getting an error on a line and you're not sure what the error is, just send it over to me. I'm always really interested to see. A lot of times if you get an error on a beautiful perfect piece of code, let's say like this on line 115 for example, you're getting an error on this line and you're like, why am I getting an error? This code is immaculate. There's nothing wrong with this code. And then a lot of times you'll have to look at the line above it and see that it's missing a semicolon. So that's just my quick plug for for bug fixing. Yeah. Yes. Okay. Last thing I want to say is if you go to shadertoy.com, you will see great examples of 3D shaders. I don't know why I didn't think about this before. Wait, latest contributions, Angel 4 by Aman. Is that our Aman? Aman, is this you? It must be. Yeah, this is Aman. Anyways, so shader toys are really great way to look at 3D shader functions. And so these are all written in fragment shaders, very much the same way that the force is. The syntax is a little different. When I say that, just the inputs and the outputs are different. So people will always ask okay, how do I fit this into shader toy? You're gonna have to look at so for example, in shader toy, time is not time, it's I, lowercase I, capital T, IME, and UV is not UV, it's frag chord, but most of the things are the same. The core of this code you could use in the force. Same with the force. It's just the inputs and the outputs that are different because they're different platforms. This is making sounds. And so the same goes with any sort of shader, any sort of shader online or any sort of like shader editor, you can probably use most of the code because it's the same, but the inputs and the outputs will be different. Anyways, let me see. I'm gonna see if I can. If anyone has any last questions, let me know. Be happy to answer. This is the page that you can submit your workshops for Codemy, codemy.com/pages/call-for-workshops. So if you have an idea and you want to be a part of that, awesome. Very, very, very. Subscribe to Char and follow her. Aw, thanks, Jordan. Subscribe to Codemy and follow Codemy. Put their stuff up here. They also have like a donate link. So this is all donation based. This workshop is it's recommended, or rather suggested donation of $20. You can give. We Codemy and I split that half. So if you, I couldn't find Codemy's donate link, but I know they have it on their website. Quick donate link. So if you go to support art and tech, you can make a donation. Donations, they accept tax deductible donations, and I have a Venmo or a PayPal. I'm gonna I'm probably gonna, if there's any donations, I'll probably split it with Amon or something like that. Or we're roommates, so we might buy a nice toaster or something. Anyways, it is 1 minute left. I'll wait for Jesse to tell me I can keep going or if I should stop. But anyways, I hope you all enjoy MUTEK. I'm going to enjoy it. I'm super happy to be here. And I hope that y'all come up with some really, really cool shader stuff. I'm going to put it back. I'm going to post this code that I made. Did I really spend all that time? Oh, here we go. Okay, cool. Okay, cool. Oh well, okay. All the code that I wrote before with this stuff is gone, but that's okay. I can put it back. I'm just gonna now. I think I'm just gonna kind of code out. I'm just gonna keep on coding. So, thank you. Probably gonna get booted off soon. Let's see. Who's next? I'm gonna code for a little bit. I'm just gonna keep coding for my Twitch channel. I think I'm booted off the, not booted, but I'm put off the MUTEK.